So, hello to another episode of Beam There Done That. I'm one of the co-hosts, Alan Wyma. Today, we also have again our other glorious co-host, Francesco Cesarini.
Hi. Yeah, Francesco Cerini, also co-host. And I'm really excited today. We'll be talking about the right tool for the job, rather than the tool at hand. We often talk about Erlang and Elixir as the ultimate tool for concurrency, scalability, and reliability. But today we want to start exploring what happens when you need to drop down onto the bare metal in order to go in and squeeze out every ounce of performance. And so, on the topic, we're joined by two experts who know exactly where the let it crash philosophy meets the zero cost abstraction world of Rust. So, Leandro and Florian, welcome to the show. Why don't you introduce yourselves?
Hello, Francesco. Hello, Alan. Hello, Leandro. I'm Florian. I was part of the Rust project for quite a while and have learned Rust in 2013. That's my claim to fame. Before that, I was actually doing 10 years of Ruby, and during that time, learned Erlang quite substantially. I used Zung in production. That was my main project that I used. And yeah, during my time at the Rust project, I was part of the community team. And the most relevant to this podcast is that meant also answering a lot of questions about could you do something like Erlang or what Beam does in Rust? And I had quite a lot of those conversations, and we can deep dive into that during this session.
Hello, so thank you for having me. I'm very excited to be talking about Elixir and Rust. I've been working with Elixir for the past 10 years now. I was doing Ruby, Java, other languages before that. And during my time with Elixir, I used to work on an early stage startup called IntelliSpark. Then I did some work at Dockyard working on the BeaconCMS project. And now I'm working on the real-time product at Supabase. And almost 3 years ago, I started working on two libraries, MDEx and Lumis. MDEx is Markdown for Elixir, and Lumis is a syntax highlighter using three-seater. Both libraries using Elixir and Rust. And I'm excited to be, let's discuss how we can make this happen, Elixir and Rust together.
Well, it's great to have people from different kinds of communities all together in the same room, and some of us have basically we've all kind of crossed over and done some. I think everybody in this room's done some Erlang at this point, if not even Elixir, and I've definitely touched a little bit of Rust. Francesco, maybe you'll be vibing some Rust now that you have some free time. I don't know. But Florian, I have a question for you. We're always interested to hear, a little bit about the horror stories. Do you mind to talk about one of the most memorable outages that you've ever caused? And I see this very, devilish smile on your face, so this might be a very good story.
I don't know what's the horror about it. So my most memorable outage was very early in my career. I was an intern at a web agency. And you know how web agencies back then went. So you basically are a junior that has to pose as a senior. So my first project was the German website of MTV, the video channel, or one of the first projects I was on. And one day in the first weeks, someone calls and they're like, we see ad revenue going down. Is something up with the website? And there it was. I had brought down the German website of MTV by a coding mistake. Classic PHP, some kind of array misindexing or something. I don't remember what the actual mistake was. That was the first time I was like, okay, maybe you should think before you deploy and not just upload files into FTP. And that's been a common thread through my whole career, actually thinking about the production chain that leads up to a deploy, and then thinking about the systems on which we deploy on and where they can save us and where they cannot, and what things we need to mitigate as humans, which one we can actually mitigate by using our tools. And that's been most of my career coming out of that experience.
Nice. Leandro, Florian just mentioned PHP. Why don't you tell us about the time you chose the wrong language or tool and shipped it anyway?
Yeah, I would say the most recent one is Lumis itself. The library I was working, Lumis was supposed to be a Elixir library, and it was not really working very well because of the integration with three-seater. Three-seater is compiling parsers to C, and I want to have a CLI for this library as well. And I was kind of hitting some walls using only Elixir, and then eventually I realized it was better to have a Rust library. And now Lumis is pretty much a Rust library with some clients. One of them is Rust Elixir client. And my point is, even with a relatively small library like Lumis, if you don't choose the right tool, you're gonna have problems. You're gonna have issues. It's gonna be hard to implement the features and work on the whatever project you're doing.
Great, thank you for that. So the first, I've met a lot of programming language inventors, through the conference circuits, for our involvement in the functional programming space, very, very early on when no one was using it in the industry. And the first question I tend to ask them is, what problem were you trying to solve? Florian, could you give us a brief history of Rust? Who was behind it, who is accredited for the main design decisions, and what problems, they were trying to solve?
That's a tough question because Rust is a bit weird. It's a group effort, so it's often hard to track who actually did what. It's often attributed to Graydon Haw, who actually kicked it off, but actually left the project even before it reached 1.0. And there are actually, before Rust even reached 1.0, you can even see generations, you can say. Like there's an influence from Haskell, because there was a group of Haskellers actually working on the language at Mozilla Research at some point. Then there's some influence actually from Erlang. At some point, Rust was actually a language that had a...
Jack Moffat was very active in the Erlang community, was actually on the Rust core team back in the early days. So yes.
Exactly. So Rust for a long time actually had a runtime. It had a garbage collector, and the whole ownership borrowing that the language is now known for was one of the aspects of the language, but not the only one. And interestingly, I'm pointing a little bit into where Rust went. At some point, there was this defining event, and I was already not in the Rust team, but around it at that time. There was this defining event when basically it was said, okay, ship or go bust. Mozilla at some point just made it very clear, okay, we need to release this as a language. And I think that was really useful, as in that was the moment where people needed to think, okay, what do we have? So you look at the language space back then, and you have Go, which is a garbage collected, kind of bare metal language, running quite fast. Maybe not the right target. No one needs Go, but from Mozilla. Then you could go towards a runtime distributed language. But this is where Erlang will eat your lunch, because Beam exists, and Beam is 20 years older, and actually building an invented runtime that as a general system is quite hard. So it was a practical decision to actually move Rust towards a runtimeless language and more go into the C and C++ space. But that was a decision that came, given that Rust was started around 2006, relatively late. So about 6-7 years in, that this actually crystallized that this is the direction that the language will go.
So where do you see it heading in the next 5 to 10 years? Because I suspect your language, it's a constant evolution.
Skipping over the 5 to 10 years since it was released, which was, let's maybe put that in the middle. So Rust has decided to play in the C and C++ space. When I was part of the community and core team and doing a lot of the talking in public about the language, we always said, we want Rust to be the best second language in your project. So if you need something bare metal, if you need something that runs very predictably, something where you have a very clear connection between the code you wrote and the execution time, then Rust should be your best pick. So very often actually in deployments like the one that we just heard about, where Rust is a core library, but the actual driver, the host of the program, is something else. And we still see Rust being very strong in that department, particularly because it's being used to rewrite or augment massive code bases that already exist. Rewriting the whole code base isn't feasible, but people pick Rust on those locations for several reasons. For the classic cases, you have a C or C++ based system, and memory safety becomes a mandate. We've seen governments talking about it. Memory safety was a word in the Senate appropriation bill which was, for me as an engineer, a little bit of a weird event. We used to not have our technical terms in the appropriation bills of governments. But for places like, taking as an example the Ruby space where I come from, or the example that Leandro shows, where people are picking Rust as the base implementation language for what I say the passive parts of their program, classic re-entrant libraries. You call in, you get data out, and they're using that because usually the host language is already a memory safe language, and they want to use a systems programming language where the memory safety property isn't lost. So one of the first adopters of Rust that I spoke to, they were augmenting their Ruby code base with that. They were producing a metrics framework. And they were saying, we just can't, our customers will leave us if after picking a language that is memory safe and garbage collected, Ruby, one of the server processes runs into a seg fault because of the plugin we put in. We need to maintain memory safety because people have already picked a memory safe language and have picked it for that reason. And this is going to continue over the next 5 to 10 years, roughly that. Rust is in an adoption phase where I don't want the arguments to change too much because people have finally settled on them and are starting growing.
Okay, excellent. Thank you for that. There's a question for you, Leandro. I mean, there's a quote by computer science professor Alan Perlis, who went in and said, the language that doesn't affect the way you think about programming is not worth knowing. So, Leandro, how did you get into Elixir, and how did it actually change the way you think and reason about programming?
Yeah, that's a really good question. Before Elixir, I was doing Ruby, and since I'm from Brazil, and so it was kind of natural for me to follow José Valim as well, since he's from Brazil as well. And Valim was on the Rails core team. And Ruby, for me, back in the day, was one of those mind-blowing moments. You when you know that you found something special that changed your way of thinking. And then when Valim started working on Elixir, I was like, why he's working on something different if we have Ruby, And then I started learning more about Elixir, and it didn't click at first for me. The distributed system model, functional programming, it didn't really click at the time. But working on 1, 2 projects, I started realizing why the bean makes the whole mental model different. And then when you realize how you can leverage, how you can make use of the bean to build more safe systems in terms of distribution, in terms of execution, then that was when I had another mind-blowing moment, and that was like 10 years ago, and I never looked back. So that's how I got into Elixir. And I think many of the community Elixir programmers came from the Ruby world as well. It was kind of natural to move from Ruby to Elixir, but it really shines when you understand how functional programming works, how the bean works, how you can leverage distributed programming. And when that clicks for you, you can really understand how you don't need to. So for those. So when I moved to Elixir, I started realizing how we can program using those bean properties to build resilient projects. You don't need to worry about the bad path, I'd say. You were about making the software right, and then the bean can take care of failures. It's a different mental model for programming. And then when you understand this model and function programming, and you have a background on object-oriented code, that's when you can combine those, and then you can understand how those works, and then you understand that functional programming is not an isolated paradigm that you're supposed to use it. Just So when I moved to Elixir and then functional programming clicks for you and distributed programming clicks for you, that's when you understand that you can leverage the bean to build releasing systems that can handle failures even under pressure. And since you have a background on object-oriented programming, you can combine both, and then you can actually have a mental model that allows you to build better systems.
It almost sounds like the value of learning a new programming language lies in kind of shifting your mindset. So not just mastering the new syntax, and the true learning kind of kicks in as you're saying when a language introduces new paradigms, such as functional, logical, or concurrency, which then fundamentally go in and change how you approach problem solving, abstraction, and code structure. And in this particular case, I think looking at Elixir, fault tolerance and scalability. Does that sum up what you're saying?
Yes, exactly. Because let's say, yes, exactly. So, for example, when I was learning Elixir, on the Elixir programming book, one of the most famous books for learning Elixir, on the very first pages, you have the verbal assignment instruction, but the book says it's not an assignment; it's a match. The syntax is exactly the same, but you have to understand what's happening behind that. You have to understand how functional programming works and how the bean works. So it's really a mental shift, especially because if you come from Ruby, the syntax is inspired by Ruby, so it's very similar. But the execution is and what's happening under the hood is very, very different.
Brilliant. Yeah, I completely agree with you. Completely agree.
Leandro, sorry to put you on the spot again. I have a question for you about the biggest mistake when you're using Rust with a Beam language, right? Because, there's a lot of things involved. I mean, the Beam itself is basically a pretty well-oiled machine as long as you're kind of playing within the bounds of, the Beam itself, like the language, all the kind of constructs. But once you add in Rust, you have a lot more flexibility in what you can do. And it's kind of like a katana, right? You can basically finely cut things, but at the same time, you can really cut yourself if you're not really careful with it. Do you mind to kind of talk a little bit about that?
Yeah, sure. So I think the biggest mistake is not understanding the trade-offs of using NIFs. NIFs are not free, and you have to be careful. And even though it looks like you are just adding a new function in your program, and then you test it on your local machine, it passes on the CI and it's running just fine, and then you deploy to production, and then it can either crash or latency can go to the sky because you don't understand how NIFs are integrated into the bin. And for example, one very common mistake is not understanding that NIFs can block the schedule. So let's say, for example, you have a NIF that is taking a second or 2 seconds to execute, and it works fine on development because the data that you have a very small set of data, or you have less load on your system, then it works fine. And then on production, it becomes a mess. It becomes very, very problematic. And even though Rust make it safer to run NIFs, you have to understand that all the properties of NIFs. Um, so NIFs are not preemptive. So as long as the NIF is running, the bean cannot take another work. So on that process. So that's one of the main problems we have with NIFs. So we have to be careful to model the NIFs on a way that's not gonna block. And people also need to understand how the schedule works. On NIFs, you can assign the NIFs to a third IO scheduler or the third CPU scheduler. They are different pool, so you can move the NIFs there, and you have to understand how those different schedule works in order to have a performing production system.
Yeah, I was just going to mention because I have written a NIF before that had to use the dirty scheduler, so I want to make sure you kind of talk about that. But actually, something that's a little bit more interesting to me is to talk about some things that we enjoy about specific programming languages that are not in others. I know for me, like the pattern matching that's inside of Elixir and Erlang is much better, I think, and much more interesting and a little bit more flexible compared to the one that's in Rust. Florian, this is over to you. I'm curious about like what kinds of features do you think that Rust would be nice if Rust had from Erlang, and then vice versa on Erlang could have from Rust?
I have to laugh a bit because I've recently written a paper with the German Avionics Institute about particular pattern matching in different languages and how it relates to software testing in avionics, because that's safety critical is the field where I'm currently have my eyes on. And powerful is a little bit of my enemy because powerful is hard to describe and hard to validate. Which features do I like? Interestingly, and this is where as much as I love programming languages, I'm very disinterested in syntax discussions. I know quite a few people, for example, say Erlang is a little bit dated. It has this prologue-like syntax. It's really out of the, it's a little bit different. And Elixir is Ruby-like. Sometimes people say it's cool or not. I don't care. The interesting thing I find about Erlang, and this is why I reach to it from time to time, is literally the runtime. This is a thing that I figure out in training and in all of the discussions that I hinted at before, is not a lot of people have intuition for complex, particularly async runtime. So if I do an async training in Rust, it's actually 50% what is even async. And then in Rust, you go and say, okay, I would like to have a task running in my favorite async library, say Tokyo. So I need to pick an async library. There's multiple out there. One of the most popular, but what if that one doesn't fit? How do I grade that? Next, I go and say, okay, and I want tasks to communicate through channels. Then I go and say, I don't want unbounded channels. I want them to have like 30 slots. Let's call this a mailbox. And then I want some management. And I want, if one of those tasks crashes, and you see where this is going, suddenly I'm building 50% of what Erlang has been, or Elixir for the matter, has been thinking about for a couple of decades in an afternoon. Which system do you think will be better? So what is the thing that I start replicating? So I take a lot from what I learned when doing Erlang, and then slowly figure out, okay, there's actually quite a treasure trove of things that are well implemented in that ecosystem already. That's really hard to match. That's the thing that I always try to replicate when I'm working in Rust. Yeah, and fail at it.
Leandro, I have the same question for you. I'm curious because you've been spending so much time in both, probably much more than Florian. What do you think about, which language feature would you want in both of those?
Yeah, it's interesting that Florian is talking about the runtime, because for me, it's good to not have a runtime, that Rust has no runtime, because that makes it easier for the integration with Elixir. So the way I usually think about this integration is Elixir is the coordinator, is the main program for me for the projects I work, and Rust is like an extension. So since it's a runtime-less language, has no garbage collector, that makes it much easier to integrate. And async is a really deep topic. I would say, for me, I avoid working with async on Rust. And the reason is I find Elixir better for async work. So that's where I kind of draw the line between Elixir and Rust. I use Elixir for the concurrent work, for all the async work with process that we already know. And for Rust, the way I see Rust in this kind of integration is like I said, like an extension. You can think it like it was a different module for your Elixir project. You have functions, and then you can just call those functions. And as long as you do save Rust It is pretty much like just another module on your system, but it's written in Rust instead of Elixir. So if you keep the Rust code isolated and you keep it kind of, small if possible, and you don't use async on the Rust side, that's where I kind of draw the line. So, but for Rust, I would say Rust, it's more about the community as well. It's not only the technical side of Rust, it's also about the community. One big advantage of Rust is having a bigger community. So you have way more libraries, and sometimes that's where you reach for Rust. If you need some kind of work that you don't have in Elixir, like a library, or even if performance reasons, then you can go to Rust. So for me, Rust is not only about the technical side of things, it's also about like a product or business decision. It helps you unblock the projects, helps you adopt libraries or unblock tasks that you might have. That's it. Either it's harder to do in Elixir, or it's just not existent, and then you need another library that does exist in Rust. So it goes beyond the technical decision.
Florian, thank you, Leandro. I think you actually answered quite a few questions I was going to ask, but let me throw the ball over to Florian. If you had to explain the difference between Rust and Elixir to a C-level exec, so a non-technical C-level exec with the attention span of a fly, what would you say?
My quick answer is, what's your business doing programming language decisions? If you don't have the background. I think this is actually a severe issue. We have far too many people having opinions about things that should be engineer level decisions. I would say, so actually, I sometimes talk to other execs in used to be member of a C-level club, and a lot of people are non-technical, and they often have this vague. I know people are talking about programming languages, but what does that actually mean? Problem as a non-technical person, and giving them use cases. Hey, this chat protocol, for example, is written in Elixir, and this is what, or Beam, and this is what it's good at. It's good at holding a lot of connections. Like, this is something that people have a little bit of an intuition for. And explaining them a little bit about the detail in 1 to 2 sentences, that Rust is really for building up these systems from a way lower level. I don't think I could do this in the attention span of a fly. If they really only have the attention span of a fly for that topic, my recommendation is keep your hands out of this. You'll only make it worse.
But so explaining it to someone technical who needs to make a decision, what problems does Rust make safe that Elixir leaves to discipline?
It's a hard question for me to answer, because I rarely try to compare languages that I have a lot of experience in, 10 years, to one that I have dabbled for a couple of weekends. In general, those questions,
I mean, try
on that level, this question isn't really asked. Yeah.
Try to think of a dynamic type system versus a static type system. Try to think of a runtime versus native. That's what comes to my mind.
So the big advantage and disadvantage that Rust has, it's close to the metal. You need to think, for example, about, what does my operating system do? I mean, we say Rust is a runtime-less language. What it actually says is, my kernel is my runtime. That means I need to learn a lot about Linux or QNX or whatever, what I'm currently running on. All of these things differ. This is very interesting in the safety critical space. Actually, the runtime and scheduling behavior is one of the big differentiators between the operating systems that you pay quite a bit of money for. And this is something where Rust gives me, I don't need to care a lot about how Rust interferes with that. That's a good aspect of the system, because Rust is kind of, as I explained, this passive language. Until I tell it to do something or to do something dynamic, it absolutely doesn't. While the moment you kick off something like a VM and a garbage collector, you have all of these things going on that might interact with the underlying system already in a very complex way. And the moment where I actually need to care about that boundary, programming languages that come with a runtime introduce more problems than they're worth. If I'm very strict about those details, the benefit of them is they are an abstraction over those systems, and if the abstraction fits, I get so much with it. I just get a very good package that I can work with that makes me care a little bit less about the underlying system. You get that direction.
Interesting. Get it. Thanks for that. And where do you think your developers usually misunderstand each language? And Leandro, yeah, we'll be asking you the same question there. So
I'll give a quick answer because that's a pretty direct example. I've been in quite a few conversations where people said Rust is better because it doesn't do garbage collection. And that's a clear sign that people haven't understood memory management. Garbage collection is a memory management technique that can be very effective if it's the right technique. It can actually be faster than naive manual approaches. And Rust's memory strategy, although it's automated through the tape system, still more akin to manual management in C. And if people go and say C is faster because the memory management, or C or Rust are faster because the memory management is manual, don't understand the work that went into all of those automatic memory management techniques that, for example, allow you to do memory sharing safely without explicitly asking for it. In Rust, even your memory sharing strategy between tasks and things like that, like referencing shared data between different components of the system, the way you put this into memory is something you have to ask for. You need to specify how it exactly works. You need to specify how it's collected. You can't delay it unless you worked on actually delaying reclamation of memory and all of these aspects. And I think this is the biggest thing, that all of those interactions are not really thought about. And we're working with these cookie cutter statements of this is better than this. And then we just form two camps and we're done.
Completely boils down to what problem you're trying to solve. Again, we always used to be told in the Erlang world, oh, Erlang's not fast enough. We were actually being called crazy back in the 90s when we were implementing telephony switches for hundreds of thousands of users using a virtual machine. They were telling us it's not fast enough. It won't be fast. No, it won't be the fastest. No, but it's going to be fast enough because you need soft real-time properties. So you're setting up a call. It doesn't matter if the garbage collection triggers whilst you're setting up that call. As long as that garbage collection is that burst is short and contained. And what people were missing, which I think is very much the kind of the theme of this podcast, is very much about using the right tool for the job rather than tool at hand. If you're using the right tool for the job, it needs to be fast enough. It doesn't have to be the fastest, but the speed you get is the speed of development, because you didn't have to worry about all of the concurrency you have and you're dealing with telephony switches. That was all taken care of you by the underlying operating system. Yeah. Leandro, over to you. What do developers typically misunderstand about each language? What do you think?
Yeah, I'm gonna focus more on the Rust side. A very common situation is thinking that Rust is only useful for low-level programming, and that's not really true. You can solve a lot of problems using Rust. And in this specific situation where you have an Elixir project and you can actually adopt Rust, solve problems in your project, not only for performance reasons, but also to extend the functionality of your system. So Rust is not only for low-level programming, and you don't need to understand all the advanced features or advanced situations in Rust. You can get started quite easily. Even though Rust requires a step learning curve, you don't need to understand the full language to adopt Rust in a Elixir project. And that's mostly because of Rustler. Rustler abstracts away the integration between Elixir and Rust and makes it way easier to have these this integration. So that's probably one of the misunderstoods when, that probably make people afraid of adopting Rust. Like, hey, I'm gonna need to write kind of C code or something like that. No, you don't need that. You can get something very easily on this integration.
Florian, I have a question for you now that because you've worked with both Beam and Rust, and you work a lot with the C++ and kind of integrating all these kind of things. There was a very interesting project a while ago. I think it's been stopped. Hopefully, it gets brought back up, which is kind of like a complete rewrite of the Beam in Rust. I know that there's this stigma of I don't know what you call that. Maybe Rust bros that want to rewrite everything in Rust. Just rewriting Rust, right? Do you feel that there'd actually be a benefit if the Beam was actually rewritten in Rust?
Okay, before I go into that answer, I want to address rewriting in Rust just quickly. Actually, my company has been involved in the first part and the current refresh of sudo rs, and this is obviously one of the big rewrite in Rust projects. And there's this meme out there that Rustaceans want to rewrite everything in Rust. And clearly, as someone who runs a business in that space, it is larger companies approach us rewriting things in Rust. Sudo rs was a customer project, or is a customer project. And we see quite a lot of those rewrites actually being demanded by larger companies. It's not a community thing. Please don't put this on the community. I know that group ed out there, the hecklers exist, but the hecklers and the people actually executing are two very different people. Now, on Beam, I don't have that much experience with runtime rewrites, but I know that a lot of people are currently looking at, could we rewrite, for example, whole RTOSes in Rust? Would it be better if the real-time operating systems we have are rewritten in Rust? The thing is, Rust is about, and this is a little bit hidden, containment of unsafety and about complexity. It's a really good encapsulation language. But that means is sometimes the internals are famously, as Rust even calls it through a keyword, unsafe. And a lot of those interactions with the operating system are something that the compiler actually doesn't abstract, but you need to turn into a type system abstraction. Once you have it, you have very good tools. For example, you have very good low-level building blocks for concurrency. And I do see a chance that, for example, those building blocks can then be used because it has a low-level lingo about concurrency. Rust doesn't know what a thread is. Rust also doesn't know what a task is, but it has all the tools to build abstractions around that. It's the only language that I know that appreciates that concurrency exists without giving you the actual implemented primitives. It's a little bit abstract. And I think those primitives are very well suited to write something like Beam and then actually rewrite Beam in it. The problem is I would like to see the actual tangible benefits on a written system, because often these kinds of, like the existing Beam and the existing operating systems that we use have been used for decades and super well vetted. I think they're the smallest problem that we have in that space. Our biggest problem, and also where you see all the CVEs and all of these things, are actually user-space code and misuse of those systems. I think that's the much bigger fish to fry. Still, I'm very interested in seeing the project succeed. So I'm looking at this with curiosity, but not with any kind of, I would say, like where I feel like there's an urgency to do this. The current system is good, in my opinion.
Yeah, I mean, the other thing to think about too is if you rewrite something just in general, you have a lot of, hindsight about what worked, what didn't work. Yeah, and also from my comment about rewriting Rust, that was obviously a joke. You often see that stuff on Reddit. So I'm not part of that crew.
Yeah.
Just want to make that very clear.
Yes, but I just wanted to take the chance to address it, because I know it's a frustration, and I know there's people, like, that's why I say, like, the group of hecklers exists. And I don't want to downplay that.
I think a similar question for you, Leandro. I'm kind of curious because you've been working with both, right? Do you feel that there'd be any kind of benefit for that? I mean, have you ever worked with writing a NIF in C, and do you see like the benefits of if you actually went ahead and did everything in Rust by itself?
Just like Florian said, I have never thought about this problem before, to be able to have a conclusion, like to have a proper. It would be interesting to see. And I know there are some Rust projects that does implement parts of the being, like the interface and others, but the whole system, it's really hard to say. That would be a really big project, but I don't have much experience on this one as well.
What pushed you, though, to follow up on this question, to build MDEx and Lumis in Rust instead of pure Elixir?
MDEx in particular, it was like 3 years ago when I was working on the BeaconCMS. The libs that we had in Elixir, they were not solving the problems I had to solve. So I had two options on this situation: either build a new Markdown parser in Elixir, or use a Rust crate. MDEx is using Rust crate called conrack, which I believe is now generating all the Markdown for Rust docs, if I'm not mistaken. And so on those two options, I had to consider all the risks and all the time it would take, to take one or another. And as a business decision, like a product decision, it's much better to adopt what is already working, which was the crate library. And that was pretty much the main driver for MDEx. Instead of rebuilding in something new in Elixir, you can just leverage what is already working on another language. For Lumis was supposed to be Elixir library, but there are two problems. One is the three-seater integration. Three-seater has official bindings for some languages. Rust is one of them, and we don't have an official binding for Elixir. So very similar problem. Either you buy, either I had to build something new with Elixir, or leverage the official binding that we already have for three-seater. So again, it's much better to just leverage what does exist, and you can just depending on the situation, you can wrap the library or you can extend. So the decision here was not only technical. That's what I mean.
What is the biggest mistake people make when introducing Rust in with the Beam? So be it Erlang or Elixir or Gleam.
Yeah, that's a good question. You have to start small, I would say. So my mini framework, my mental model when adopting Rust into Elixir is keep it small, keep it contained. Like I said before, I avoid using doing async on the Rust side. I prefer to coordinate the async work on the Elixir side. And you have to understand the schedule, like how the schedule work. And also another problem I have seen, and that was probably the bugs I had in MDEx and Lumis over the years, is the encoding when you're passing data between Elixir and Rust. And that's where you can actually crash the process at runtime. You can have like a correct Rust code, safe code, but if the shape of the data is not correct, is not what is expected between the boundaries, it's gonna crash the process. It's not gonna crash the VM, but it's gonna crash that specific process. And sometimes you only find this problem in production, which is a problem. So you have to understand the how to pass the data between the boundaries. And in terms of performance, you also need to understand what you have to pass between the boundaries, and when you can leverage more advanced features, like for example resources. Resource is how you can resources kind of like a pointer. So you have some space of memory in Rust, and then you have this resourcing pointing to that space. And then this resource is, you can pass between Elixir and Rust. And some libraries make extensive using of this, because instead of passing data over back and forth, you can just have a resource. And then on the Elixir side, you can just give some instruction, or you can give some instruction from Elixir to Rust, and Rust is going to operate that process, is going to operate that, going to do some operation instead of passing data between the boundaries. But that's more like advanced feature of Rustler and this integration. But sometimes, if you really need performance, you need to understand those operations as well. Because if you are passing too much data between the boundaries, you can have problems as well.
Rustler is the main library used to interface Rust. Where does Rustler shine, and when does it become risky to actually use it from the beam?
If you, yeah, that's, I would say not Rustler itself, because Rustler, it's very stable, and it has been in development for some years now. It's very, very stable. So it's not much about Rustler, I would say. It's more about understanding how, if you keep the Rust code safe, you have less risks of running a NIF. One property of a NIF is that NIFs can take down the whole VM. If you have, for example, a C code that seg faults, for example, it does have like a segmentation fault, it takes the VM down. The whole beam goes down. On Rust, that's more or less of a problem if you do only safe Rust. But that's more like a NIF property than Rustler itself. I would say for Rustler, one good project that you have to use along with Rustler is also Rustler precompiled. It's a project by Philippe Sampaio, and essentially it does compile the Rust code for you. So, and it generates a binary. It makes the binary available for you, so you don't need to recompile the Rust code over and over again. And that means in your development machine, for other developers, and for people using your libraries, or even for deployments. So you have a pre-compiled binary. So that's another project that it's important to use.
Florian said you've been left out for a while. Maybe just wake you up a little bit while you're waiting. I was kind of curious though. What does a typical Rust backend stack actually look like if you're actually going to be deploying this in production?
Oh, that's a classic Rust backend stack. There's been the joke in the Rust community for a while that every week a new framework. It's slowly gravitating to people use Axum and SQLX. Axum, I would not consider a full web framework. It's more, I call these things HTTP acceptors. It accepts HTTP messages, routes them, and does something with that and triggers actions, which nowadays, in the time of Phoenix and Rails, I wouldn't consider a framework. And SQLX being a SQL database access layer. That's the normal one. There's quite of a variety around. So this is kind of what it gravitates towards. It's feeling more like the JavaScript world in 2012, when the default stack didn't really exist. But that's, for example, for all of our backend services, that's what we use if we build them.
Now, I want to ask about if I'm going to be adding Rust into an existing system. Let's just say Rust just makes sense in this situation. You know that it becomes a little bit complicated because things can how would you say that? You know, they kind of bleed over. Like you can do some things in Rust, you can do some things in language X. Where should I be looking at? Like at what point should I say, okay, the boundaries here, Rust is going to be doing this stuff, and then language X will be doing this kind of stuff?
I think if you already have an existing system, I think the first question to ask is, do we have a problem that needs fixing? Every time I see someone just doing a language for the language's sake, it always ends up in tears. In particular, when we are engaged in these situations, the first thing we check is, does the existing system have problems? Second, is this a problem that in the existing scope, for example, it's an Elixir project, could be fixed by actually calling up a circle of friends that know Elixir? So is this actually a problem that merits a rewrite, or is this just people need help digging themselves out of a hole that they've built themselves in? It happens all the time. This is not a judgment call, but this is something that we as externals need to do. And then if there's a substantial problem with the current system that cannot be fixed with the current tool stack, that's a question. One of the things where we are, for example, see backends being rewritten in Rust is people have very high needs for a consistent response time in the milliseconds range. And that's a question you need to ask yourself. Am I of such a scale that milliseconds ranges within response times are actually a topic for us? This is also something that people we find are often super honest with themselves. They're often a magnitude off in the scale that they think they're in. And when that all is done, then we find for an appropriate way to actually switch to a second technology. This moment, your code base becomes a multi-language code base with all of the problems that it has. And then it could either be something where you, for example, do an in-process thing where you say, this is a slow function, we'll rewrite this as an if, we'll use Rust, things like that, which comes with all of the problems that Leandro mentioned. This may lead to situations where at the boundary, you need to do data re-encoding or things like that. Or pretty often, we just rip the whole part out and deploy it as a separate service. Other reasons for rewrites are often, for example, just better availability of base tooling. Like discussed before, I want to do Markdown. Good Markdown parsers exist. Do we need a Markdown parser in Elixir, or can we just reuse one that exists in a different ecosystem? But I would not consider that a rewrite. I would consider to say, okay, we're actually deciding to build the next generation of a product in something else.
Now, when we start to actually integrate Rust into an existing system with other languages, what are some of the typical problems that you see?
Well, the biggest problem is actually the boundary, is because basically the moment your languages interface with each other, we're talking about what's called the C ABI. That's at the core of it. There's a misunderstanding that the C ABI is in any way standardized. It's actually a semi-standard because it's mandated by your platform, which is your operating system and partially your compilers. Then you need to find a way of how to encode your data into that ABI, which basically has pointers and values. Very minimal explanation of what it is. And very often we see problems where, for example, then you need to know about the internal encoding over on the Elixir side. You need to know what, for example, the standard library types of Rust expect. And sometimes you need to pay a cost for converting between the two. And the thing is, that cost can actually be so substantial if you're doing a lot of calls over that boundary that performance-wise, it's not worth it. We've seen people actually doing that, thinking, okay, we get more performance out of it and paying all of the performance gains they got by Rust on that boundary. So the boundary is important. The other thing is, if you get the boundary wrong, then you're still in unsafe land, because we don't have any safe programming language to programming language interaction at the bottom, and tools like Rustler actually build a framework around that and making that safe. So that's a substantially big problem. However, in Rust, it's a surprisingly advanced problem, because the thing I mentioned earlier, Rust being the best second language in your project, the binding generators and the language-specific binding generators are extremely good. Even if they declare themselves as 0 point something, they're incredibly advanced and used in some of the biggest tools out there.
Just to start wrapping up, at least with my Beam Elixir / Erlang hat on, if it's IO bound, you'd start with Elixir. If it's CPU bound or type safety is critical, you should consider Rust. And if it's unclear, you first make it work, then you make it beautiful. And then if you really, really have to, you optimize with Rust. Mm-hmm. Are we in agreement here, or?
That's a good strategy.
Great.
Yeah.
So, Florian, one question to you, just to wrap up, some food for thought here, is what is the one thing Elixir developers should learn from Rust?
I think one thing that Rust is really worthwhile looking at is especially how it does encapsulation and how encapsulation is important. The second thing is Rust is a really, really strict language, also in its rules, and particularly in its rules on how it manages memory. This whole ownership system where every value in the program is only owned once and then flows through the program, and the compiler actually tracks it, is really, really useful to learn and structures your thinking around how values flow through your program. And this is something that I much more structurally apply when I'm nowadays coding in non-Rust languages. And previously I've done this. Everyone, I think, learns this through discipline, this kind of ownership management, like which part of the program is currently responsible for what. Rust puts it in the time system. That means it's really hard teacher on, have you thought about this? Have you thought about this? Have you thought about this? Then it's fine to go back. This is actually a feedback that we hear quite a bit for people who have been exposed to Rust, that it's a language worthwhile learning, even if you don't continue practicing it for the next couple of months. Yeah,
Absolutely. I completely agree with you. And Leandro, one thing Rust developers should learn from Elixir.
That's a very tricky question. For me, it's hard to say, like, because both languages, they have the pros and trade-offs, and the best of both is they don't try to be one or another. But what I like about Elixir is that Elixir is not focused on just one domain. With Elixir, you can do from distributed programming, you can do machine learning, you can expand, and you can actually use Elixir on a lot of those domains, to the point where you can use only Elixir even for bigger projects that have a lot of demands.
Leandro, one last question for you. When is adding Elixir over engineering?
So if you have I think that expand the what Florian was talking before. You first need to understand if you have a problem to solve, right? And adding Elixir is not gonna solve problems magically if you don't understand how the bean operates. So if you have a problem, like if you need to solve like real-time problems or distributed system problems, then using Elixir and the bean can be very helpful. But if you don't have the problem, just don't use it, right? So that's pretty much continuing what Florian said before. Elixir can solve many problems, especially with distributed systems. But unless you don't, if you don't have this problem, just don't use it, right? So that's where you can get into, you can over engineering your system.
So it's basically, if you're reaching out, for a tool out of habit, you're probably making the wrong choice here. And I think the final takeaway, the goal here isn't purity. It's about systems which survive production, and it's very much about using the right tool for the job, rather than the tool at hand. And most important, and hopefully this podcast will have helped you, is having the knowledge and context to make that decision. When is it we're using the right tool for the job? Just for the record, this episode was recorded on May 5th, 2026.